Hey y'all, here we go. Back again with some more factoring, but this time, what happens if your A value is greater than 1? Dun dun dun! Guess what? Nothing happens, it's different. It's the exact same thing, which is the beauty of the area model. Nothing changes. So check it out. Are you ready? Because I don't think you're ready for this factoring. Psych, you are. Let's go. All right, first things first. We need to identify, is there a greatest common factor? Nope, there isn't. So now I'm like, what's my A value? It's 2. What's my B value? It is 13. And my C value is 15. Same exact deal. A times C, 2 times 15 gives me 30. My B value is 13. So, quick recap, I'm looking for factors of 30. So, what multiplies to 30 that can add up to 13? So, I'm looking, I'm like, well, I start at the easy one, 1 and 30. That gives me 31. You're out. I have 2 and 15. That gives me 17. Nope, out. I have 3 and 10. That gives me 13. Oh, look at that. Ding, ding, ding. 3 and 10 work. So now I can use that 3 and 10 and throw them in the area model. This top left is whatever that quadratic piece is, so 2x squared. Bottom right is always your constant. And then the other two are for these wonderful factors here. So we have 3x and we have 10x. Now, just like before, we pull a common factor out of each row and each column. So in this column, my common factor, I definitely have an x in common. And do I have anything between the 2 and the 3? Nope. So now here, I don't have an x in common, and between 10 and 15, they both have a factor of 5. Now I want to look at my rows. Now, beauty of area model, if you get stuck, you can always look and see what factor you've pulled out and be like, well, what times that would give me this green piece, right? So, for example, here, if I have 5 times what gives me 10, I know it's 2. And since there's an x in there, it has to be 2x. So let's check and see if that's true. 2 is a factor, the greatest common factor of 2 and 10. And they both have an x in common. So there we go, 2x. Here, they both do not have an x. And the common factor between 3 and 15 is 3. Look at that, y'all. We are done. We have our 2 binomials, 2x plus 3 and x plus 5. We factored it. So if you would like a factor tree like you normally did with smaller, like regular old numbers before they threw letters into math and got it all confusing, it's exactly like that. Factor tree with those two. Now, what if it asks you to solve? That's not a whole different story, but you guys have done this before. I take each one of those and I set it equal to 0. So 2x plus 3 equals 0 and x plus 5 equals 0. And then I solve a little two-step equation, little two-step cancels. I have 2x equals a negative 3. I divide by 2. I'm almost done. I have x equals negative 3 halves. Can I leave it improper? Yes. Yes, you can. Subtract 5, they cancel. X is equal to negative 5. 2x values, and that is absolutely acceptable. Good to go. We have solved, and we have factored. Boom! Next one. I look. Do I have a common factor between my 3 terms before I factor? I do. I can make sure that I divide out a 2 from all of these. So I put my 2 out in front, parentheses, 12 divided by 2 is 6, x squared. 2 divided by 2 is a 1x. And negative 2 divided by 2 is negative 1. Now, if you are forgetful like me, because I've had to redo this video because I forgot to do this. I do in real life actually rewrite this 2 and then put my 2 binomials looking like that. So I don't forget that this 2 exists later on. Now, maybe it's because I have old lady brain. I don't know, but that's how I roll. All right. Same deal. Here's my A, here's my B, and here is C. A times C gives me 6 times -1, which is -6. B value, 1. Boom, boom. Now, this is negative, my A times C, which means one of my values has to be positive and the other one has to be negative. It's adding up to a positive number, which, think about it logically, that means the greater absolute value of the factors here would have to be the positive one. So if we're talking about -6, the greater absolute value would be 6, the other one would be -1. If I add them together, I get a +5. You ain't it. So let's go to the next one. I have 3 and -2. When I add those together, +1. Ding, ding, ding. I found them. No need to look further. I'm going to now take my quadratic term right there, 6x squared. My -1, I put that down here. And then I have 3x and -2x. I'm going to pull out a common factor from each row in each column. I feel like I sound like one of those movie people. In a world where factoring is important. So here I have 6x squared, -2x. I know they have an x in common, and they also have a 2. Now, if you're like, hold on, well, one's positive, one's negative. How do I know what this is? It's always the one that's closest to like that edge piece, to that term that you're pulling out. So if this is what we're looking at, we would go with the one right on the other side of it, and it's positive. Here, we don't have an x in common. It's a -1. So the only common factor would be 1. Again, since this positive is here, it would be positive. Pulling a common factor out of this column, they both share an x, and a common factor, greatest common factor of 6 and 3 is 3. So that would be 3x. You can use my trick from the last example. If we know this 1 is accurate, 1 times what gives me 3x? It's gonna be 3x. 2x times what gives me -2x? We know that's a -1. But if we didn't know that, common factor of -2x and -1 is -1. I take my 2 binomials and I put them into these lovely parentheses that I already created, so I didn't forget that 2 that tags along. And there we go. I factored it. Congratulations, me. Now, here we go. I have to solve, maybe. Who knows? Who knows? Did it tell me to solve? If you're in geometry, you're going to be solving for probably all of these. So 2x plus 1 equals 0. 3x minus 1 equals 0. Now we subtract 1 from both sides. They cancel. 2x equals -1. Divide by 2. Divide by 2. And I get x is equal to -1/2. Add 1. Add 1. Cancel. 3x equals 1. Divide by 3. Divide by 3. X equals 1/3. And I'm done. 2 answers, 2 solutions. Great. So I've solved and I've also factored. All right, last one, y'all. I need to factor this. I'm not liking the looks of these numbers. They look big to me. Can't take a common factor out. 17's prime. And 17's not a factor of 12 or 6. So it looks like we're going to need to take our A value, multiply it by our C value, and see if it adds up to, find factors that add up to our B value. So let's go. We have A times C, which would be 12 times 6, which is 72. And B is -17. All right. factors of a positive 72 that add up to a negative 17. Again, they'd either both have to be positive or both have to be negative. In our planet, you can't have two positive numbers that would add up to a negative number. So they would both have to be negative. So negative 1 times negative 72 gives me negative 73. You're not it. So we have negative 2 times negative 36 gives me negative 38. Not it. Negative 3 times negative 24. Negative 27. We're getting a little closer here. Negative 4 times negative 18 also works. And that gives me negative 22. And then, y'all, I could also have negative 6 times negative 12. But that gets me a negative 18. Oh my gosh, we're so close, eh? So let's go with our negative 8 times negative 9. And ding, 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 that's a negative 17, eh? Don't ya know, don't ya? I found them. They were hidden. So I'm going to take my 12x squared. I'm going to put that here. I'm going to put my 6 right here. And then I'm going to take my negative 8x and negative 9x. Okay. Now what we're going to do is we're going to put out a common factor of each row and each column. So looking at this first column, I have an x in common, and a common factor of 12 and negative 8 is a positive 4. And in this column, I would have a negative 3. Now, if you're like, hold on, Miss Mags, let's look. Why? Because this is negative, this is positive. How do we know that's negative? Remember, it's the one right on the other side of that wall there. All right. We have an X. We have a 3. And then this last one, we have a, let's see, common factor, 2. But it would have to be negative. Because remember, right here, wall, negative, negative. There we go. I'm done. I'm going to write what I got using my area model as 2 binomials. If I wanted to check my work, I could multiply these 2 binomials using the area model, and they would multiply together to get this trinomial. Amazing how math works. What if I need to solve? Let's work it out. I have 4x minus 3. What are we setting it equal to? 0. And I have 3x minus 2 equals 0. I add 3, cancel. 4x equals, trace, divide by 4, and I get x equals 3/4. 75%, 75 hundredths. So now I have 3x equals 2, divide by 3, and I get x equals 2/3. So if you needed a factor, you could leave it right there. If you needed to solve, you just gotta set it equal to 0 and solve that multi-step equation. All right, y'all. Hopefully factoring is a little bit easier for you now. If not, check this video out again.